Okay, today we are going to be continuing with learning target 3 from unit 7, which is I can use transformations to prove theorems about lines and angles. And today we're going to be looking at the perpendicular bisector theorem. This is going to come in really handy as we begin to complete proofs regarding triangles. So the perpendicular bisector of a triangle is a line, segment, or ray that is perpendicular to a side and divides the side into two equal halves. Also meaning that it bisects the side. And just a reminder, in case perpendicular is not a word that you remember, perpendicular means that it intersects at a right angle. So you'll be looking for those right angle symbols to let you know that it's going to be a perpendicular bisector. So perpendicular bisector may or may not start at a vertex. Okay, so if we have an equilateral triangle, then your perpendicular bisector is going to intersect the vertex of, or each vertex of that triangle. However, if you have obtuse triangles, your perpendicular bisector is not going to necessarily cross through a vertex, and we'll see that in some of our future examples. So a triangle has three perpendicular bisectors because it has three sides. So our theorem that we're going to be looking at today, our first theorem, is perpendicular bisector theorem. The perpendicular bisector theorem states, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And again, hopefully we can use our etymology. Equidistant just means exactly how it sounds, equal distant from the endpoints of the segment. So what does that look like? So here, if CD, if our bisector CD is a perpendicular bisector, so it'll have that right angle, then AB, if CD is a perpendicular bisector of AB, then AC, which I can draw in, AC right here, is going to be equal to BC right there. So if CD is a perpendicular bisector of AB, then AC is going to be congruent to BC. And if we're talking about transformations, what would make that true? It would be a reflection. We would see that AC could be reflected across the perpendicular bisector to map onto BC. Now we also know, because it's a bisector, that AM is going to be congruent to BM. So let's put this into use. So for example 1, solve for x. So here I can see that I have a perpendicular bisector, CD, and since it's a perpendicular bisector, I know for a fact that AB is congruent to DB, so AB is congruent to DB, and again we could know that by reflection. So if those are congruent line segments, that means that our values are going to be equal. So I'm going to set these two expressions equal to each other and solve. And I'm going to go ahead and pause the video. I'm going to let you solve through that on your own, and we'll check back in just a moment. Okay, so hopefully you worked through that and you got the answer that x equals 6. We can double check that that's our answer by substituting it back into our expressions. If we did 7 times 6, which is 42, plus 10, it would give us 52. if we did 9 times 6, which is 54, and we subtracted 2, that would also give us 52. So we know we did it right because those two line segments are the same value when we substitute in our value for 6. So looking at the second part of example 1, again, we're using the perpendicular bisector theorem. Now this does not tell us, but we are just going to, because I am telling you, it is a perpendicular bisector, which means that AM is going to be congruent to BM. So I'm going to set up AM is congruent to BM, line segment. And so 3x minus 8 is going to be congruent or equal to 2x. And so you can go ahead and solve that. I'm not going to pause the video for this one. If we subtract 3x from both sides, that gives us negative 8 equals negative 1x. And then if we divide by negative 1, we get x equals 8. So x is equal to 8. And again, we can verify that that's the answer. If we have 3 times 8, that's going to be 24. Minus 8 is 16. And then 2 times 8 is also 16. So we know, check, check. We know those are both correct. Now, every theorem typically has a converse, and that converse is going to kind of be the reverse of the theorem. So if you noticed up in our perpendicular bisector theorem, you'll notice that I capitalized the words if and then. So in the perpendicular bisector theorem, it says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. The converse usually takes those two statements and flips them. It reverses them. So our converse of a perpendicular bisector would state if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. Okay, so notice that we just kind of reversed the if and then statements. And depending on, once we get to proofs, depending on where we're at within that proof and what we need to prove, will determine whether or not we're going to use the theorem or if we're going to need the converse. And so really the converse of the perpendicular theorem would say that if AD is equal to BD, then D lies on the perpendicular bisector of AB. And that goes back to our picture up here, that if, let's use different colors. So if AD is congruent to BD, then point D is on the perpendicular bisector. So that would let us know that those would be perpendicular. Okay, so let's put this to use. Example 2, we want to find the length of AB. So I can see that I have a perpendicular bisector. I can see that it bisects AC into two equal parts. And again, because of the perpendicular bisector theorem, that tells me that AB is going to be congruent to CB. So I can set up my problem as such. 5x equals 4x plus 3. And if I go ahead and solve this, subtract 4x from both sides, and I get x equals 3. Okay, just to verify, 5 times 3 is 15, and 4 times 3 is 12, plus 3 is 15, and that checks out. And so for me, for the question, it says find the length of, find the length of AB. So AB, line segment AB, is equal to 15. And we can say 15 units, or just 15. If we look at example 2, it says find the length of AB. And again, we can see that we have a perpendicular bisector. And so we're going to set our two line segments equal to each other. Okay, so go ahead, solve this problem, and see how you do. Okay, so hopefully as you went through the work, you got that x equals 12. If you plug that in, you'll see that both AB and AC are going to be equal to 30. Therefore, the length of AB is 30. If we move down to example 3, here we're using the converse. It says BD is a perpendicular bisector of AC. Find AD. So we need to we set our two line segments congruent to each other or equal to each other. 3x plus 14 is equal to 5x. And then we can go ahead and solve. So if I subtract 3x from both sides, 14 equals 2x, which would leave me with x divided by 2, and x equals 7. Okay, so if I plug that in, 3 times 7 is 21, plus 14 is 35. So we have 35, and then 5 times 7 is also 35. So I can say that AD is equal, line segment AD is equal to 35. And go ahead and try this last one. I did put a note here to pay attention to what you are actually solving for. So go ahead and pause your video now, solve for AC, and we'll see how you did. Okay, so hopefully going through your work, you set those two line segments equal to each other because they are CB and AB are part of AC that was bisected, and remember bisected means it's put into two equal parts. So we set those equal to each other, we solve, we got y equals 5, and then when you plug that in, you get that each line segment is equal to 13. However, in our question, it says to find AC, which is that entire bottom length of that triangle, so I would have to add those two sections together, and that would give me that line segment or side AC is equal to 26. Okay, that's the end of these notes. I know they went quick today. Yay. Your practice is on Google Classroom today, not on Delta Math, on Google Classroom. It's a PDF. You're going to use your PDF writer to solve the problems just as you did here. If you choose to print them out, that's fine. You'll just need to re-upload the pictures onto Google Classroom to assign them or to submit them so that I can check your work. Good luck. If you have any questions, stop by during office hours between 12:30 and 1:30 so that I can answer any questions. Okay, good luck. Bye.